All right, let's dive in. We're going to tell a story today, a story about relationships, about competition, and about growth. It's a story that starts with a little fish you probably recognize, and well, it ends with us. We're going to see how the rules that govern a tiny corner of a coral reef can actually help us understand our entire planet.
So every big story starts small, and ours begins with some of nature's most fascinating and sometimes strangest friendships. Believe it or not, these tiny one-on-one interactions are the very foundation for every ecosystem on Earth. I mean, if you've seen Finding Nemo, you know these two, right? The clownfish is just hanging out in the anemone's poisonous tentacles, totally safe. How does that work? Well, it gets protection from anything that wants to eat it. Plastic gets to snack on leftovers. And what does the anemone get? The clownfish's bright colors actually act like a lure, drawing in food for the anemone. It is a perfect win-win situation, and it's happening all over the ocean.
So, that special deal between the clownfish and the anemone, that's just one tiny thread in a huge web that ecologists call a community. And a community isn't just the address where these creatures live, it's all the different populations. The fish, the coral, the algae, all living together and interacting. It's those relationships that really make the whole place come alive. So, how do all these different species actually interact with each other? It really boils down to three main categories that shape life pretty much everywhere on the planet. You either eat something, you compete with something, or you cooperate with something. These are the basic rules of the game.
First up, let's talk about predation. It's the classic circle of life, right? One species eats another. We see the lionesses here, preying on the zebra. But here's a little twist for you. In its own way, the zebra is also a predator. It preys on grass. And that constant flow of energy, from the grass to the zebra to the lion, that's what keeps the entire ecosystem running. Okay, next rule, competition. This is what happens when everybody wants the same thing, but there's just not enough to go around, whether it's food, water, or a place to live. Now, sometimes one species just outcompetes the other, and that's that. But a lot of the times, something way more interesting happens. Species adapt. They specialize. And this is a perfect example of what I'm talking about. In the rainforest, you've got all these different kinds of anole lizards, and a lot of them eat the exact same insects. So instead of fighting all the time, they've basically divided up the territory. Some hunt on the forest floor while others stick to the trees. By carving out their own little niche, they can all live in the same forest without stepping on each other's toes. And that brings us to our final category, symbiosis. It's a fancy word that just means living together, and it covers any close long-term relationship. We can break it down into three types, and it's super simple. You've got mutualism, where it's a plus for both species. Then there's commensalism, where one benefits and the other is, well, it's not affected. And finally, you have parasitism, which is a plus for one and a minus for the other. Here is a fantastic example of mutualism, that plus-plus relationship. This little shrimp is nearly blind, but it's a great digger. It carves out a burrow that it shares with a goby fish. In return for a safe place to live, the goby, who has amazing eyesight, acts as a bodyguard. It keeps a lookout for danger and warns the shrimp. They're a perfect team. Then you've got commensalism, the plus-zero deal. A hermit crab needs a shell for protection, right? So it finds one from a snail that's already died. The crab gets a much-needed home, and the snail is long gone. It doesn't care one way or the other. One benefits, the other is completely neutral. And last, we have parasitism, the plus-minus relationship. This roundworm, for example, lives inside a host animal. It gets a free meal and a safe home, all at the host's expense. But here's the really interesting part. Most parasites actually don't want to kill their host. Think about it. If your home and your food source dies, you're out of luck. So a successful parasite is one that can keep its host alive for as long as possible. Okay, so we've looked at the one-on-one rules of how species get along, or don't. So now let's zoom out. How do all these little interactions add up to affect the size and health of an entire population over time? This graph tells the story beautifully. Take a look at the orange line. That's the prey. As their numbers go up, guess what? There's more food for the predators, which is the blue line. So a little while later, the predator population shoots up too. But, more predators mean more prey get eaten, and the prey population crashes, and with less food around, the predator population falls right after. It's this natural, endless cycle of boom and bust. Of course, in the real world, a population can't just grow forever. This S-shaped curve shows us a much more realistic picture. So a population starts growing pretty fast, but eventually it starts hitting some limits. Maybe there's not enough food, not enough space, or too many predators. The growth slows down and eventually levels off at the absolute maximum number that the environment can handle long term. Ecologists call this limit the carrying capacity, or just K. And this idea is absolutely crucial. So, keeping all these rules in mind, predation, competition, and especially carrying capacity, let's turn our attention to the most mind-blowing population story on Earth, our own. Just look at this graph. For almost all of human history, our population grew at a snail's pace. And then, boom, around the 1800s, our population curve just goes vertical. It took all of human existence to reach 1 billion people in the year 1800. We've added the last billion in just 12 years. So the big question is, what on earth changed? Well, the answer has to do with something called the demographic transition. For most of history, we were stuck in stage 1. Lots of babies were being born, but lots of people were dying too, so growth was super slow. Then came stage 2. Thanks to things like better sanitation, more food, and modern medicine, death rates suddenly dropped. But, and this is key, birth rates stayed high. And that's what caused the population to explode. It's only later, in stage 3, that birth rates start to fall, and then in stage 4, the population finally levels off. And these population pyramids give us a perfect snapshot of this process. On the left, we have a country like Angola in 2005. That's a classic stage 2 country. See how wide the base is? That shows a huge number of young people and a super high birth rate, which means really fast growth. Now, look at Sweden on the right. It's in stage 4. It looks less like a pyramid and more like a column, right? That means low birth rates and low death rates. It's a stable population with close to zero growth. The difference is just incredible. Today, different countries are all at different stages in this transition, but globally, our population is still growing and fast, which brings us right back to that fundamental ecological question, but now it's on a massive scale. What happens next? Well, most projections suggest that by the year 2100, there could be around 10 billion of us on this planet. That forces us to ask a really tough question, using the language we've been learning. What is Earth's carrying capacity for humans? And maybe even more unsettling, have we already passed it? So, what do we do? Where do we go from here? Well, experts generally point to 3 different paths forward. The first is basically a technological one. We innovate our way out. We find ways to increase Earth's carrying capacity through better farming, clean energy, you name it. The second path is behavioral. We collectively decide to change our habits, maybe slow down population growth, and definitely reduce how much stuff we consume. And the third path is more social and political. It says maybe the problem isn't about making more, but about distributing what we already have more fairly. Of course, these paths aren't totally separate. The real solution is probably going to be a mix of all 3, but they do represent really different ideas about how to build our future. Our whole story started with this simple, balanced partnership between a clownfish and an anemone playing by clear ecological rules. It ends here, with us, a global society facing the exact same principles. The question isn't what the rules are anymore. The question is, what are we going to do about them? Which path do we take?